I know that there are lots of applications of convolutional neural networks with different deep learning frameworks on MNIST dataset, but I will be reproducing the result of MNIST example again. But the reason for that is I want to ask you some questions to convolutional neural networks and identify the potential problems while applying uh, our Keras code uh, while to the real-world applications. The reason to choose Keras is actually I uh, don't want to make your head busy with uh, determining the parameters of convolutional neural network, and I don't want to make you crazy with TensorFlow's syntax. I just want you to focus on the problems and solving the problems with other libraries. And after that, after this course, you can always learn TensorFlow, PyTorch. They have also some advantages while compared to the Keras. But the other reason to choose Keras is we can apply transfer learning and fine tuning very easily on Keras. So the reason is transfer learning and fine tuning can be applied easily, and you can uh, get the results of transfer learning and fine tuning very quickly. So that I thought that we should start with Keras and we should start with MNIST example to not to make you busy with syntax of other deep learning frameworks. Also, I want to make you ask some questions to convolutional networks while every stage of coding. Uh, I will be posting this blog. I do not know who is the writer, who is the author. However, the code looks same with the other codes available on the internet. Probably it's uh, taken from the Keras documentation, Keras's documentation, and the importing dataset part. I don't want to make you busy with and steal your time with writing them. I have it my Keras on my Python file. Also, for any potential case of use, we will be importing NumPy. And also, now we need to load MNIST dataset. However, we see that we can easily load MNIST dataset and we don't have a problem with splitting into training and testing dataset. Let's import it with Keras library. We will be using MNIST dataset. So in MNIST function, we'll get load data, and also we will be naming these images such as X train and Y train. Also, we need to have test dataset. We will say X test and Y test. And now at this stage we download the dataset in two categories: training and testing. And I want you to ask the question of uh, is it that easy to load dataset to Python system like this one line of code? And let's write it to the right side of the code. Is it that easy to load the dataset? And also now we should identify the size of image and in two parameters. One of them is the row of the image and the other one is the column of the image. And these are in this problem, these are 28 to 28, and I want you to ask the question of what is the standard of the pixel number, and also you should ask the question of uh, do they do these images must have the same uh, pixels. Actually, I want to answer this. For the whole dataset, the images should be in same pixels. Also, there are some standards of it. For example, uh, in uh, in some of CNN architectures, you can see this kind of pixels 299 to 299, and also you will be seeing 224 to 224. This is the mostly used pixel in convolutional neural networks. However, the image that you collect can has the images that has very different pixels. However, you should resize it to these number of pixels. We will be talking on that problem uh, in the other lectures. But and we need to identify the batch size. Batch size is actually the number of images that you load at the same time, and uh, at that stage you can ask what should be the value of batch size in the same time for the one training epoch. How many images should I load to the Python system? And I want to say that we should also consider the RAM usage. If we need to use, if we have RAM problem, we should lower the batch size parameter. And also number of classes, we know that we have 10 classes from 0 to 9, and for epoch we have 15 numbers of epoch. It means that our convolutional network will see the whole dataset for 15 times, and you can ask that how to determine the value of epoch number. This is also a good question. Actually, this doesn't depend on any number. I mean, this depends on not to 15, not to 20, but it depends on your accuracy and the loss. Actually, we will be talking about them, and also we will be arranging the data uh, according to the now we determined the number of epochs. Actually, this is like alchemy. You need to try and find the solution according to your experiences and trials, and this depends on your dataset. This depends on your convolutional network architecture, and also the other problem is, and let's print the let's print the shape of our dataset. I mean, the shape means the shape means your dataset's pixels and your dataset's image size, and you see that we have 6,000 of images that has 28 pixels to 28 pixels, but Keras needs that this dataset should be like this, because this means your color channel, RGB channel, and you need to expand your dataset according to this format. And in in the blog of uh, Mohitat, you see that there are some ugly codes like that, but we will be now easily handling this and asking another question, and we will say that our X train is actually uh, uh, X train must be expanded uh, from its dimensions, and now we will expand it to according to the first axis. I mean, if you are familiar with NumPy, 0 and 1 means horizontal and vertical, and also, and then we will be reshaping it to the -1. -1 means let's write the rest and then talk about it. Reshape it to the images that consist of 28 to 28 pixels and one color channel. In MNIST dataset, we know that uh, the channel consists of there are only one channel, and it tells that 0 is black and 1 is white. According to that, you see the images of MNIST dataset. And the -1 means if you have 28 pixel to 28 pixel images, the rest is the rest can be handled by NumPy. When you train this, when you apply this, you see that uh, uh, of course we need to see the shape of it. You see that your dataset becomes like that. So the difference is the one color channel, and we will be applying this to the whole of training and testing datasets. And while doing this, uh, I don't. I want to ask you a question that uh, do these pixels must be the same for every image in the dataset? And of course you will be saying yes, because you see that we need to reshape every image to the every pixel. So we need to make them, we need to make every image uh, in the same pixel numbers. So now we are expanding the dimensions of our dataset, our images, and also while doing that, we are now also seeing how to use NumPy uh, during the uh, interact with Keras library. And now we now handled the dataset problem for this easy uh, problem of MNIST dataset. And now we will be talking about scaling your image to some format. I didn't plan to talk about the image, because I assume that you know about convolutional networks and images, but I can add some videos uh, to the uh, course. But now we will be talking about scaling our dataset. The image consists of three channels, RGB channels, and in these RGB channels, you see that there are numbers of 0 to 255 and 255, and you see that these are not scaled into 0 to 1. To scale them and to not suffer RAM problems, and also to not suffer to don't create complication due to these big numbers, we should resize it to the 0 and 1. While doing this, we will be using simple Python code, and we will say that divide x train by 255, and also divide y train with 255. And but the question that you should ask is, do you have to scale it between 0 and 1? Because there are some scaling advices that you can see on the internet, but these advices mostly depends on the applications of the image datasets. Uh, Actually, you can see that the advices are from the applications of convolutional networks on ImageNet dataset. You see that in ResNet models, in the article of in the paper of ResNet models, they say that we scale according to the system, and the advice that you can see online are advices that you can see online are based on that. So the uh, question that you need to ask is now, what should be the format of scaling? What should be the format of scaling, and uh, are there any other scaling methods? Actually, there are lots of scaling methods, -1 to 1, 0 to 1, or zero-centered. There are zero-centered scaling methods, and most of them most of convolutional network use zero-centered scaling methods, but we will be talking about them later. Now, before going on to the uh, coding part of it, we have the last stage, and for that we need to arrange the labels for our uh, dataset. To arrange the labeling, we will be using Keras's data utils sublibrary, and we will be using Keras's two categorical subcategory submethod, and while doing this we will be writing y train and number of classes, which is 10, but we identified it in here. So this makes the labeling part, and I should be sorry for the training dataset part, because I have a mistake on that, because our labels are not pixels, so I forgot to I didn't realize it. Well, let's delete them. So our images are now prepared, but uh, before going on to the arranging the output, arranging the y's, let's see the initial dataset for y that is provided by Keras system. Well, we are seeing that these are some numbers here. Actually, these are scaled between 0 and 1, and probably this means uh, these two same numbers means the same category. For example, these are probably 2. But now we are now arranging it with Keras's to categorical method, and when if we print y train after the to categorical method, now we will be seeing that these are on one-hot encoding methods. So one-hot encoding methods. Well, now we handled the input and output, but now I can say that for preparing the dataset, you won't be dealing with white train and white tests. You won't be dealing with uh, these kind of ugly numbers. We will be handling the labeling. Actually, Keras can handle the labeling with its image generator function or data loader function, or we can also prepare the output dataset with NumPy using, for example, NumPy tile method, and also with uh, by hand we can arrange these kind of datasets, like, for example, this means 0 on our dataset, on our MNIST problem. We can create a dataset such dataset similar to this using some NumPy functions, and we can see that with NumPy tile tabi we didn't write the repetitive parameter. So while using NumPy, we can also handle the dataset with NumPy tile, and then reshaping and rearranging these NumPy array. We can also arrange the output dataset. And in this part, we asked questions on preparing the dataset, and we will be after that, after the coding and seeing the results of MNIST example, we will be also analyzing these questions and arranging these questions to see the problems of applications of convolutional neural networks on Python. And after arranging the problems, we will go into the solutions uh, with different libraries and different problems. And we will be solving different problems with these libraries.